a question about refrigerant and what it's doing inside the condenser. On my left here, I have a pressure enthalpy curve. Some of you may remember this from your studies in your apprenticeship, but if you haven't, what this particular graph depicts is the movement of refrigerant through the components of your system. And actually, I can follow that movement for you right now. Your vertical axis over here is increasing pressure, and your horizontal axis here represents increasing enthalpy or heat content in the refrigerant as it circulates through the system. So, for example, if refrigerant enters the compressor here, it is pumped up to a higher pressure and temperature, picking up a lot of enthalpy and pressure. Then it enters the condenser and it travels along this horizontal line until finally it enters the metering device. From the metering device, we get a sudden pressure drop. And of course, with that pressure drop comes a temperature drop where we enter the evaporator, absorb heat through the suction line, and back to the compressor where your refrigerant can complete its cycle. But our question is about what's happening to the refrigerant in the condenser. Well, it enters the condenser right here at point A, right here. And at point A, it's going to de-superheat. That high temperature it picked up from the heat of compression is rejected in the first few passes of the condenser to point B. And once we reject enough superheat to bring that actual refrigerant down to its condensing temperature, we begin saturated conditions and we keep rejecting more heat, changing that hot gas to a liquid until we get to point C. In the last passes of the condenser, the actual refrigerant will be rejecting even more heat, reducing its temperature, but now it's all liquid, so we will subcool from C to D, where we finally enter the metering device. So what's happening to the refrigerant in the condenser? Well, actually, everything's happening. We're de-superheating the gas from A to B, we're changing from a vapor back to a liquid from B to C, and we're subcooling that liquid from C to D.